All right, well, everybody, welcome to our first lecture, our first official lecture, which is on signed numbers. As I mentioned right before I started this recording, our book, like since we're in this co-requisite course, we don't really have a section in our book that's titled like a section 1.1 or whatever. This is kind of preliminary information that I'm using for us. So there's not really a section name. You could probably just like put the date or whatever. But this is going to be signed numbers, specifically integers at the moment. Now, one thing I do want to make sure we mention right off the bat is that because this course has no prerequisites, we have a bunch of different places where we are coming from. Some of us haven't. I mentioned this in the intro video, but some of us haven't seen math in 20 years. Some of us just took it yesterday, right? So we're going to go. I'm going to go in with the basis, with the assumption that we're either needing to know all of this stuff, or it's been a while since we've seen it. So if this seems like something you already know, please just bear with us. It might be that you see something different, or like a neat trick that I do, but some of us might not know these things. Okay, so that's the reason why we're going over it. So one of the most important things that we have in this course is that we need to know going into the rest of it is how to add and subtract and multiply and divide numbers. You can use your calculator for a lot of things, right? I'm totally fine with you doing that. But there's a couple things that I'm going to require, that I need you to be able to do for this course that you shouldn't need a calculator for. And I'll explain more in a second. So the first little section is the addition rules. The addition rules for signed numbers. And this is broken up into two main bullet points, right? So bullet point number 1 is that when adding two numbers of the same sign, add the values and keep the common sign. So when you're adding two numbers that have the same sign, so either they're both positive or both negative, just add the values and keep the common sign. And I'm going to show you an example here in a second. So two things that I want to mention before I get carried away. So once again, I mentioned this in the intro video, but my brain is pretty scattered in the first week of class because there's a lot of things, a lot of nuances of me as a teacher and things that I want you guys to know. And they come up randomly, and I want to bring them up. So the first thing is that mathematicians have notoriously bad handwriting. All of my professors did, except for a handful. I don't have the best of handwriting, but I like to think I'm better than a lot of my colleagues. And I'm still not perfect. You should see my wife's handwriting. She's way better than I am. Point being, if I ever write something that you can't understand what I wrote, please just say hey, can you tell me what that word is, or something. I won't take offense to it. I know that my handwriting's not the best. One thing you're going to notice about me, and I could probably work on it, I probably should work on it, but my THE, always ends up being like this congealed mess. So look at that. That is a the right there. You can clearly see the E right there, right? You guys can clearly see that's an E. Of course. And there's a better one right there. That's clearly an E. That's clearly an E, guys. Anyways, I'm just being silly. Point is, once again, if you can't read what I'm writing, or if you need me to rewrite it something, just let me know. I don't take offense to it at all. The second thing is it's completely optional, and you probably already see it right now. I really, really, really recommend that you use color in your mathematical notes. I didn't start doing it until I reached my senior year of college, and it was such a revolutionary change for me because it really makes math come alive. And you don't even need that many colors. Like, the more colors you have is awesome because then you can just make it really pretty fun. But really, all you need is a pencil, a black pen, a red pen, a blue pen, and a green pen. You can probably even get away with just a pencil, black pen, red pen, and blue pen. But I like to also add green into the mix. So I will be using color. You don't have to, but I really recommend it. I've had students that never did it before my class, and they said that it was very, very beneficial. It kept them more engaged. It kept them it made them be able to work through their notes faster, like to study through their notes faster. So, anyways, that's an option. You don't actually need to do it unless you want to. Okay. So let's actually look at some examples. So, if you had 3 plus 5, these have the same sign. They're both positive numbers. So we just add them together. 3 plus 5, that's 8. And we keep the common sign. Since they're both positive, this sticks out to be positive. Another example would be something like -3 plus -5. That would be, here, they're both negatives, right? They're both there's a -3 and a -5. So we're going to add the values, 3 and 5, which gives me 8, and then we're going to keep the common sign, which would be -8. Does that make sense? Does any questions on that? We will do practice, by the way. We'll try and do as much practice as necessary. I want to do one more, and then we'll talk about the second rule. So the last one would be -4 plus -6. This time, once again, they have the same sign. They're both negative numbers, -4 and -6. I wanted to I did this deliberately, by the way. You might be asking yourself, well, why doesn't this have parentheses? If it's the first term in the set, you don't necessarily need to have parentheses around it. It's just when you're writing it, when you're writing another term and you're putting a symbol in between them, like an operation like plus, minus, add, subtract, it would look really, really funky. Don't write this down. It would look really funky if you wrote -4 plus -6. It doesn't look right. Does that make sense? So, point being, these are both negative numbers, so the result is going to be a negative number. We're going to add the numbers, so 4 and 6. 4 plus 6 is 10, and we're going to keep the common sign. That's a negative sign, so this should be -10. So, that's the first rule. When you have the same sign, add the numbers, keep the common sign. The second one is a little more tricky, and it's when adding numbers, when adding two numbers of unlike signs. So I'm going to underline that. When you're adding two numbers of unlike signs, subtract the values and use the sign of the larger number. So subtract the values in the most natural way, and you'll see what I mean in just a second. Sorry, a student said, are you going to have definitions on tests and quizzes? Great question. So as a small aside, a student said, are we going to have definitions? Like, what is the definition of blah? Or what is the distance formula? And the answer is no. I don't like to put definitions unless it's an absolutely necessary one, but I don't foresee that being the situation here. I haven't made all my tests yet, but I mean, I can tell you, I could probably, in my 10 years of teaching, I can probably count on one hand the number of times I've actually put definition problems on my exams. Okay? Good question. Yeah, of course. So, you're going to subtract the values in the most natural way, and you'll see what I mean in a second. And then you're going to use the sign of the larger number, quote unquote, the larger number. And you're going to see it's best done through an example. So, as an example, let's just say we had 3 plus -5. So these are two numbers with opposite signs. The 3 is positive and the 5 is negative. So the values are 3 and 5. I know it's -5, but like the core point of this is the 3 and the 5. So we'll do the subtraction. We'll do 5 minus 3, which gives us 2. But what's the sign? Is it positive or is it negative? Now, there's a lot of ways you can do this. Yes, a student says negative in the chat, and they're absolutely right. Now, ideally, you won't need to do this after a while. I hope that you can do, you get to the point where you do this in your head. But 5, I'm gonna leave a little bit of a comment here, and I'm gonna use pink this time. 5 is the bigger number. And has a negative sign. Five is the bigger number, have a negative sign. So our answer will be negative. That is to say, that is to say that 3 plus -5 should be -2. Well, I don't need to box that answer. Oh, okay. Another good question. Unless there's I'm gonna get to that question of the student. It's closely related to what we're going over, but I want to ask: are there any questions on how I got the -2? Oh, don't apologize. Do not apologize. It's a very, very good question. So, it doesn't look like there's any questions on this. So I'm going to go over, I'm going to talk about this question the student has. They said, are we going to cover any sort of proofs in this class? And the answer is yes and no. So I will go over some proofs every once in a while. Yeah. Another student says, "Can we do one more problem?" Absolutely. We have about 3 or 4 that I've got here. So don't worry. We're gonna do more. But with regards to proofs, this actually brings up another question. Another point that I wanted to bring up about my course. You can always ask me why something is useful. Like, why do we do this? Why is it useful? What is it used for? I love answering those questions. And the more important one for me, at least, is the thing I love about mathematics the most is that everything has a reason why it works. And you can always ask me the reason. Sometimes I won't be able to go over it in class because it might take too long, but I'm always happy to stay after class or talk to you in my office hours or send you an email about it. You can always ask me to do it. So back to your question about proofs, is that sometimes in certain areas I will give you a proof. Most of the time I will say, this is a theorem or this is a fact. If you want to know more, please let me know, but I just don't have the time to go over it. But every once in a while I'll throw in a proof. That being said, you will never be, I cannot foresee a situation where I'm going to ask you to prove something. Proving is more, like proofs and stuff, is more of an upper division math concept. So yeah, there might be some proofs in lectures, but there shouldn't be any in your homeworks, okay? Of course. So let's do one more example under this little bullet point. So 6 plus -4. Now I'm not going to write all the stuff that I did here, but I'm going to talk through it. And then we're going to go over some practice, and I'm going to let you guys work on it yourself, and then I'm going to slowly fill in details. Okay? So here, these have opposite signs. The first one is positive, the second one is negative. So in my head or on some scratch paper, I'm going to do 6 minus 4. Those are the numbers, right? Those are the values, 6 and 4, which gives me 2. There we go. And then we keep, so should this be positive or negative? Well, it should be positive because the bigger, like 6 is the bigger number and its sign is positive. So we're going to keep the sign of the bigger number, so this should be 2. Any questions on that? While I'm waiting for questions, there one more thing. Sorry. It's going to happen. I promise you we won't have as many interruptions as we go on further into the course. But the other one, I don't think I mentioned it last time, but I did want to mention it. I realize that sometimes I look very, very intimidating. I know I got this really, really awesome soul patch that's very, very intimidating. You can't see it on the camera, but I'm 6'1". I want to believe I'm 6'2". I can look pretty intimidating sometimes, and sometimes when I say, "Are there any questions?" it sounds a little intimidating. I don't mean it to be. I may look like a lion, but I'm really just a house cat. So please don't feel embarrassed to ask a question or intimidated to ask a question. I love answering questions. It's my favorite thing about being a teacher, okay? But anyways, it doesn't look like there's any questions, so we'll go ahead and put some practice on the board. So practice. So evaluate. Part A will be -3 plus 10. Part B will be -3 plus -6. It's a pretty bad 3. I'm going to erase that and say -3 plus -6. Part C will be 13 plus -5. And part D will be 0 plus -1. Now I want you guys to work on these yourself. Feel free to, I'm going to slowly fill in details. That's something I do in my course. And there's a reason for that, so continue to work on these problems, but I want to explain the reason why I do this. I'm not doing this so you can just sit on your phone and wait for me to get the answer. Mathematics is a contact sport. It's it requires you to get into it. It's kind of like lifting weights or playing sport. I can tell you how to shoot a basketball. You shouldn't trust me on that because I do not play basketball very well. But I could show you. You could read every book on how to shoot a basketball, like all the tips and tricks of bending your knees, using the power should come from your legs or whatever. But it's not going to do anything unless you're actually going out and practicing those skills. So it's really, really important that you try it yourself. Does that make sense? So go ahead and do those. I'm going to slowly fill in details. And you know what? I'm just thinking about this with regards to the recording. So if a student is watching the recording afterwards, it'd be kind of awkward to just have this, this awkward silence while you're waiting for things to do it. So from now on, if you're watching the recording, what I'm going to do is I'm going to pause the video, and I'm going to you should pause the video, work through these problems, and then the problems will show up on the board after a second. So pause the thing right now if you're on the video, and then do the problems, and then when you're done, press play again. All right, I have the answers up on the screen. If you didn't finish at the same time, no worries. We're going to go over them real quick. And this is one more thing to mention, by the way. Just because I remember feeling this way with one of my teachers, who would go lightning fast and basically never ask her questions. So it made me feel like I didn't know anything. Keep in mind, so I'm doing these pretty quickly, and keep in mind I've been doing math for I've been teaching math for 10 years, and before that I was a tutor and an undergraduate and a graduate student in mathematics. I've had a lot of practice with this stuff, so it's probably not going to be the case that you're faster than me at some of these things. That's okay. That's what we're here for. So please don't get discouraged if you're not doing it as fast as I do. Okay? Just bear with me. So let's go ahead and talk about the first one. This has to do with the second case. We have opposite signs. We have a -3 and a +10. So we'll do the subtraction in our head, the natural one, which would be 10 minus 3, which gives us 7. And to determine the sign, we look at the larger value. 10 is the larger value, and it's positive, so we keep the positive. That's why it's positive 7. Part B, negative 3 plus negative 6. They have the same sign. They're both negatives. So we'll just add the numbers. 3 plus 6 is 9, and keep the common sign, which is negative. Negative 9. Similarly here, or not similarly, these are actually opposite numbers, opposite signs. So positive 13, negative 5. Do the natural subtraction. 13 minus 5 is 8, and keep the sign of the larger number, which in this case would be 13, which is positive, so we keep the positive, and we get 8. And I threw in kind of a little tricky one right here with 0. So we're going to talk about it a little bit later, but if you add 0 to anything, it just stays the same. That's a very, very important one, and you don't need to use your calculator on that. Whenever you're adding 0, that's not changing the problem at all. So this just becomes negative 1. That being said, we could do it. Do the natural, this is technically positive. It's not, 0 is neither positive nor negative, but for the context here, it's better to think of it as a positive number, though you actually could think of it as a negative number, I guess. Either way, so 0 minus 1 would be negative 1, 1 minus 0 would be 1. Keep the sign of the larger number. 1 is a bigger number than 0, so you keep the negative. But it's better to just think of it as adding 0 doesn't change anything. We're actually going to use that fact a lot in your mathematical career, is that adding 0 doesn't change anything. You'll see what I mean once we get a little bit later in the course. I think about week 4 or whatever is a very classic trick that mathematicians use. But we'll do that a little bit later. Any questions on that? All right, looks like we're good, so we'll move on to subtraction of signed numbers. All right, so subtraction rules. All right, there are 2 main rules. The first one is that subtracting a number is the same as adding its negative version. What I mean by that, in an example, is that if you had, let's say, negative 3 minus 5. If you had negative 3 minus 5, that's the same thing as negative 3 plus negative 5. And I'll explain why in just a second, in case you don't know why that works. And then, like, 7 minus 4 is the same as 7 plus negative 4. Now, the reason, the way I like to explain this is to think of positive numbers as we like to think of numbers as money. In particular, positive numbers are checks that you're getting, and negative numbers are debts, right? And the other thing is that addition is adding something to you, and subtracting is taking away, right? That's the intuitive idea of what subtraction is. It's taking away, whereas addition is adding something. So, in that context, you got negative 3 minus 5. If you're subtracting 5, you're taking away a positive 5. You're taking away a check for $5. That's essentially the same as adding a debt of $5 to yourself, right? Does that make sense? So, if I take away 5, that's the same thing as adding a debt of $5. That's why negative 3 minus 5 is the same thing as negative 3 plus negative 5. Now, why do I do this? Why would I do this at all? Well, the reason is that this makes subtraction into an addition problem. It's a very, very classic thing in mathematics is to take a new concept and relate it back to an old concept. Maybe one that's better to grasp, that you can grasp better. So basically what we're doing with subtraction is we're converting it to addition by changing the subtraction sign to an addition sign and making the number negative. That's the first main rule. And the second rule is that subtracting a negative number cancels to addition. I.e., if you have, and I'm going to put this in quotation marks, if you have minus and then parentheses another minus and then a number, that becomes addition. So this, let me actually write that a little bit better. This turns to just addition. And you'll see what I mean in just a second. As two examples, so if we had -3 minus -5, what some students like to do here, and it's kind of cute, is you make this into a plus sign. That being said, I don't like to do that. And the reason why is later on, pretty soon actually, we're going to have multiple terms inside parentheses, and you need to distribute that minus sign, so it's not a good idea to do that. It's better to just think of it as changing it to addition for that number. So this becomes -3 plus 5. Subtracting -5 is the same thing as adding 5, and I'll explain in a second because I want to do the next one. If you had 7 minus -4, that's the same thing as 7 plus 4. Now, why does that work? To give you the intuition, going back to this money example, -5 is a debt of $5. And I'm subtracting that -5. So I'm taking away a debt of $5. That's essentially adding $5 to my bank account because I don't have to pay that check or pay that debt, right? So by subtracting -5, I'm taking away a debt of $5, which is really adding $5 to my bank account. Any questions on that? Student says, sorry, I'm just processing, and that's totally fine. Feel free to take a second. If you have a question, please feel free to ask. I'm going to continue onward if that's all right after a second more. But if you think of a question, please feel free to ask it, and we'll go back. Okay? I have no problem. Notice at the very bottom here, right down here, the recording doesn't see this, but for the people watching the video, we can always go back to a previous page. So. And I didn't do these, I didn't actually write the answers because this is what we just did. We did addition, and we just learned how to do addition with signed numbers. Here, they're both the same sign. They're both negatives. So we'll add the two numbers. 3 plus 5 is 8, and keep the same sign. So -8, so on and so forth. So let's do some practice. Example. And always, please let me know if I go to a new page too fast. Just tell me to go back, okay? So, example, perform the operation. A is going to be -2 minus -7. Part B will be 4 minus 10. Part C will be -12 minus -12. And part D will be -2 minus 0. Sometimes, with regards to my notes and how I work, sometimes, don't worry if you don't have those written down. I'm coming right back to it. Sometimes I write the answer right next to it, like this. I just gave the answer right away. Other times, I like to write down the problems and then write the solution below it. So SOL apostrophe N is my abbreviation for solution. I want to go over part A together, and then I'll let you try part B, C, and D on your own time. If you want to do them all right now, feel free to, and then you can just check your work as you go along. Well, we got -2 minus -7. we're subtracting a negative, which is the same thing as adding the positive version. So this is going to be negative 2 plus 7. We've converted it to an addition problem, and these are now two numbers with opposite signs. Going back to the first page of our notes, when adding two numbers of unlike signs, subtract the values, keep the sign of the larger number. So, subtract these numbers. 7 minus 2 would be 5, and 7 is the bigger number, so this will be positive 5. Any questions on that? All right, looks like there's no questions, so go ahead and do parts B, C, and D. If you're watching the recording, pause the video, try and do those ones, and then we'll go ahead and have them up on the board after you come back. All right, I'm going to continue onward. If you don't finish, keep working. Otherwise, we're going to go over them. So, part B, 4 minus 10 is the same thing as 4 plus negative 10. That's two numbers that are being added with unlike signs. One's positive, one's negative. We'll do the natural subtraction, which would be 10 minus 4, and that would give you 6. And we keep the sign of the larger number, which would be the 10. So the 10 has a negative sign, so we're going to make this negative 6. This one, negative 12 minus negative 12. That's the same thing as negative 12 plus 12. That's the same number, but opposite signs. They add together, they give you 0. And last but not least, question D. Subtracting 0 is basically the same thing as adding 0. It doesn't change anything. And that kind of makes sense. If I didn't give you anything, if I took away nothing, I took away nothing. It didn't change anything. If I added nothing, nothing changed. So that's that. And I'm going to move to the next page unless there's any questions. All right. As a little note, what happens if there's more than just two numbers? Well, when simplifying a longer expression, change all subtraction to addition. And then simplify and simplify. So, as an example, simplify. Part A will be negative 1 minus 3 minus 8. And part B will be, let's see here, this is going 15 minus negative 5 minus 3 minus negative 13. While you're writing those down, I want to mention something. So, if you can do these in your head, I want you to get to that point. That's my goal at the end of this course, is that you can do these things in your head. Okay, there we go. Scene glitched out for a second. And you can use your calculator when these are really, really nasty numbers, like 71 minus 35 plus 18 minus 127. Like that type of stuff. Feel free to use your calculator to do that. I don't need you to do that in your head. That's tedious. But I don't want you busting out your calculator for things like what we've been doing right now. I want you to get to the point where you're comfortable doing those by hand or in your head. Okay. So, solution. We're going to go through A together, and then I'm going to let you guys do part B. So negative 1 minus 3 minus 8. As a small note, remember, this is not subtraction here. This negative sign, this minus sign here, that's not subtraction. That's just attached to the 1. That's a negative 1. Subtraction has to be between two numbers, or between two variables and stuff like that. So this becomes negative 1 plus negative 3 plus negative 8. We were subtracting 3, and I'm going to convert that to addition. So we're adding a negative 3. Subtracting 8, we're going to change that to adding a negative 8. So What we'll do is we'll work in parts. We'll work with this part first. -3, -1 plus -3. Those are numbers with the same sign. So we add the two numbers together, keep the common sign. 1 plus 3 is 4, keep the common sign. That gives me -4. And we'll bring down that plus -8. Once again, these numbers have the same sign, and we're adding them together. So we're going to add the numbers, keep the common sign, which gives us -12. All right, I'm gonna let you guys work through part B. Feel free to pause the video if you're watching this at home, like watching the recording. Okay, I haven't finished this one, but I wanted to talk about it because there's two ways you could do this. You could break this down into it's gonna take a couple ways to do it. You could either add this together, then add the result to the -3, then add that result to the 13, or you could break this up into two pieces and add those two pieces first. It doesn't matter. However you want to do it, it's totally fine with me. So the one way to do it would be, like the way I would do it, the way I think would be a little bit clever, is to do this together, which would be 20, and this together, which would be 10, right? 13 minus 3 is 10. Keep the sign of the bigger number, which would be the 13, so positive. And then we've got that plus sign bringing down, which gives me 30. You could have just as well decided to do 15 plus 5. You don't need to write this down, but you could have done 15 plus 5 to give you 20, plus that -3, plus that 13. Then work on this, which would give you 17, plus that 13, which would once again give you 30. That's another way to do it. But not necessary. Let your freak flag fly and do it however you want. Okay. Oh, I'll probably keep that up for just one more second. And we're going to move on to multiplication and division of signed numbers. So multiplication / division of signed numbers. So the first thing that I want to mention is a note. There are many different ways to express multiplication and division. So 4, and then if you draw a little tiny x and then say 6, or if you do parentheses 4 times parentheses 6, or if you do 4 and then parentheses 6, or if you do 4 and then a little dot and 6, all of these are the same. They mean the same thing. Those are all different ways to represent multiplication. I will caution you to not use this. Do not use this in this classroom, and I will never use this. That's a thing that we do originally when we're working with it, but once we start including variables, this multiplication symbol and an x get really, really complicated and really, really tedious, and it's bad. Division, on the flip side, so 10, this is the way it's normally written. It's normally introduced as 10, and then this is the division symbol in 5. But later on, and this is the way I want us to write it, is you could write it as 10 / 5, or more preferably, 10 over 5. These are all the same as well. These mean the same thing. All right? Now, when multiplying / dividing two numbers of the same sign, the answer is positive. So, in shorthand notation, if you, oh, sorry, I didn't mean to go that page. If you have a positive times a positive, that's going to give you a positive result. If you have a negative times a negative, that gives you a positive result. If you do a positive divided by a positive, that'll give you a positive result. And then if you do a negative divided by a negative, you'll get a positive result. So multiplying and dividing things of the same sign, like two things of the same sign, will always result in a positive. And I'm going to hold on this page for just a second before I move on. And if you need me to go back, just let me know. And the second thing is when multiplying, write that better. When multiplying / dividing numbers of unlike sign. So when multiplying and dividing numbers of unlike signs, the answer will be negative. So, written in shorthand notation, if you have a positive times a negative, the result is going to be negative. If you have a negative times a positive, the result will also be negative. So these would be two numbers of differing signs. They'd be unlike signs, like 5 and -6, or 2 and -3, whatever you want. And then if you have a positive divided by a negative, that's going to be a negative number. And if you have a negative divided by a positive, that'll also be a negative number. So that's kind of the rule. If they're unlike signs, they'll be negative. If they're the same signs, it'll be positive. So, as an example, evaluate. Part A will be 3 times 5. Part B will be -3 times 5. Part C will be -12 times -1. And part D will be... Wait. Oh, sorry. I just saw the chat. Sorry about that. We're gonna go back for a second. And we're back. And part D will be 36 divided by -4, and part E will be -20. Sorry, no. -14 divided by -7. All right. This is going to be kind of weird. I should have just put them all in a line instead. So, but I'm going to put the solution over here. So part A, 3 times 5. So, is the result going to be positive or negative? Should be positive. They're the same sign. Very, very good. Very good. So they're the same sign. So the rule says that the result will be positive. So this should be positive 15. Part B, -3 times 5. Well, here we have differing signs. We have unlike signs. We have a positive or negative times a positive, which will result in a negative. Very, very good. So this will be -15. Just do the multiplication. So 3 times 5 gives you 15, and the result will be negative, so we'll keep the negative. Part C, -12 times -1. This result will be positive because they have the same sign. A negative times a negative is a positive. And one of the things that we'll write down a little bit later today is one of the rules is that multiplying by 1 doesn't change anything. Multiplying by 1 doesn't change anything. it keeps the same number. It's kind of it's the multiplicative. They call it the multiplicative identity, which is a fancy name to just say when you multiply by 1, it doesn't change anything. 0 is the quote unquote additive identity, meaning that if you add 0, it doesn't change anything. So this will be 12 times. This will be 12 times 1, which is 12, and we're going to make it positive because it's a negative times a negative. So positive 12. Part D, 36 divided by negative 4. The result will be negative because we have a positive divided by a negative. We're in this case right here. 36 divided by 4 is 9, and we make it negative. So this is negative 9. Last but not least is E, negative 14. Ooh, I forgot the 1. Negative 14 divided by negative 7. Same signs. They're both negative. So we're in the first case from the previous page. Negative divided by negative is a positive. 14 divided by 7 is 2. So this becomes positive 2. All right. Any questions on that? All right. Excellent. Perfect. So we'll go ahead and we'll make it we'll add a little bit of kick. We'll add a little bit of paprika. I know paprika doesn't really add too much spice anyways, but you get the idea. Maybe some cayenne pepper. Let's add a little bit of kick. So we'll do another problem, and we're going to do this one together. So what would be, simplify, or evaluate, 3 times negative 9 times negative 1. So, this is 3 numbers, right? What do? This goes back to one of the properties of our real number system that is called commutativity of multiplication and the associativity of multiplication. Which like I'd encourage you to, if you don't know what those are, I'd encourage you to look them up. But basically, commutativity means that you can jumble things around in multiplication and addition. But that's besides the point. You can jumble things around however you want to see them. And associativity means you can multiply whatever 2 terms you want to first. So you could either multiply 3 and negative 9 first, or you could multiply 9 and negative 1 first. It doesn't matter. I'm going to do these ones together. That would be 3 times negative 9. That would be negative because it's a positive times a negative. 3 times 9 is 27, so we get negative 27. And we're multiplying that by that negative 1. That's a negative times a negative, which is a positive. And that gives us 27 times 1, that's just 27. And we're going to make it positive, so positive 27. I'm going to do one more of these, and then we're going to talk about a rule, and then we'll go on from there. Let's do simplify. Ooh, wrong color. Simplify. Negative 4 times negative 2 times 3 times negative 7. There's a lot of ways we could do this. We could do it by in steps. We could do this first, then this, then this. Or we could do it like this and this, and this and this. That would be the faster way. And that's the way I'm going to do it. So I'll work with these ones. This is a negative times a negative, which should be positive. Should be positive 8. This is a positive times a negative, so the result will be negative, and it'll be a negative 21. And so we're multiplying those two things together. The result will be a negative because it's a positive times a negative. And that should be 168. Okay, so going back to this example here, student said, I'm confused on how the negative 27 became positive 27. So, the reason why it became a positive 27 is because we're multiplying by a negative 1. So these two numbers are both negative. So a negative times a negative becomes positive. And we're multiplying 27 by 1, and that doesn't change anything. The multiplying by 1 doesn't do anything. So, and I know I'm saying I'm multiplying by 1, but we're really multiplying by -1. What I mean by that is like that's the thing we're doing on the side, and then we're going to keep the sign based on the rules. I hope that makes sense. Excellent. Thank you for letting me know. And then 8 times 21. This one, I'd be totally fine with you using your calculator to verify it. That's a pretty big number. But this will be positive times a negative, so it should be negative, and it'll be negative 168. So, with regards to these two problems, one thing I want you to know, how many negatives were there in this problem? There were 2 negative numbers, and our result was positive. Here, there were 3 negative numbers, and the result was negative. What's going on there? Is that a rule, or is that just luck of the draw? And the answer is it's kind of a rule. So fact. Multiplying / dividing an even number of negatives together results in a positive number. So multiplying and dividing an even quantity of numbers results an even quantity of negative numbers results in a positive number at the end of the day. To give you an example of this, let's say we had negative times a 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 negative. 6 negative numbers, right? The reason why it becomes positive is you can, if it's even, if there's an even quantity of them, you can just pair them off. This is a positive number, this is a positive number, this is a positive number, and a positive times a positive times a positive is a positive. So this becomes a positive number. Same thing with division and stuff. If you divide by 4 negatives, it's going to be positive. Whereas multiplying / dividing an odd number of negatives together results in a negative number. And to show this one, let's just do 5 negatives together. So if we have a negative times a negative times a negative times a negative times a negative, the thing is with an odd number, there's always going to, with any odd number of things, there's always going to be one thing that doesn't have a buddy. So we can pair up these guys, that'll be positive. We can pair up these guys, that'll be positive. But this poor guy doesn't have a buddy, guy or girl, or it, or whatever. It could be anything. Doesn't necessarily need to be a guy. It could be a girl. It could be anything. But point is, these two things buddy up and they become positive because if they have the same sign, when you multiply them together, they become positive. So negative times a negative is a positive. These things multiply together, they result in a positive, but we still have this leftover negative. And that's why our result will be negative. So that's just a useful rule, and I'm just gonna we're gonna go over an example. After I'll wait for a second for you guys to write it down, because I know I write fast. I do know that I write fast, and I think I didn't mention this in this class. I forgot to. I'm originally from California, as I mentioned in the first class. And one thing I've noticed about Californians is that we talk very, very fast. In fact, and the other thing is, I'm sure you know this, when you get excited about something, you start to talk even faster, right? And mathematics is one of my absolute passions in life, and I'm very, very happy. Like I love talking about mathematics. If anybody lets me, I will do it forever. Um, so sometimes I don't realize that I'm starting to talk really, really fast. So you can always tell me, hey Phil, can you slow down just a smidgen? And I'm always willing to do it. It might be that I just didn't recognize it. One of my favorite little tidbits while you're writing this down, my first semester teaching, I was checking my students' notebooks because that was required for our course, our coordinated course. And one of my students had a completely blank page in their pamphlet. And I was like, is it because I'm like talking too fast or is it not making sense? And this girl was so sweet. She was like, no, I'm just a slow writer. It's not your fault. And the girl next to her went, yes. She gave me a devil stare and said, yes, you're going too fast. So I gave her a 0 in the class. I'm of course kidding. But no, it was an eye-opening moment for me. So sometimes I may be going too fast. All right? Just let me know. So I'm glad there's another California, so you know what I'm talking about. Okay. So let's do one example, and then we'll talk about some other useful tricks about numbers, and then we'll call it a day. So the first, like this one, I'm going to do -4 times 5 divided by -2 times -1 times, let's see here, times, let's do 10. All right. Without figuring out what this is the answer going to be positive or negative? Without going through and simplifying everything, right off the bat, do you know if this thing is positive or negative? It's going to be negative. Yes. And it's okay if you didn't get that the first time. What I want to mention, there are 3 negative numbers. There's 1 negative number in the numerator, 2 negative numbers in the denominator. A total of 3 negative numbers. That's odd, which means result will be negative. That's the rule. One way you can think about it, and this is actually very useful later on, the negatives here kind of cancel out. Like the way I like to write it is this negative and this negative cancel. But then this -1 doesn't have a buddy. He doesn't have anything I can cancel with, so that's going to stick around. And that's going to be the issue. So, -4 times +5, that's a negative times a positive, so the result on top would be a negative. That'll be a -20, because 4 times 5 is 20. In the denominator, I'm going to do this all in one step. -2 times -1, that's a negative times a negative, which would be a positive. So that would be +2 times +10. Positive times a positive is a positive. 2 times 10 is 20. So we get -20 over +20. That's a negative divided by a positive. The result will be negative, which is exactly what we were expecting. So 20 divided by 20 is just 1. So the answer is -1. Any questions on that? Okay. So, those are all the facts that we need to know. There's also some other useful facts about signed numbers. So some useful facts. The first one is that 0 times any number is 0. Is 0. It's one of the most important properties in my opinion. So if you have a big chain of things, if one of those multiplications is 0, it gets wiped out. So that is, as an example, if you had 0 times 12, that's 0. -7 times 0, 0. Hell, even 0 times 0 is 0. Pretty nice. And just to kind of make make a thing that I've been subtly doing, notice that in each of these situations that I just did, I used a different way of representing multiplication. Right? Here I'm using a dot, here I'm using parenthesis and no dot, here I'm using 2 parentheses. The reason why I'm doing that is to tell you that there are many ways you can represent something in mathematics. And we need to be comfortable with all of them. That's one of the big problems in mathematics, in my opinion, is that there's no standardization of notation. I remember in one of my graduate classes, if you know what the absolute value symbol is, the absolute value symbol later on in mathematics gets used for a bunch of things, and there was a problem where the absolute value was used in 3 situations, and each of those situations meant a different thing. It was awful. Anyways, I'm getting sidetracked. So that's the first property. You don't have to worry about that in this class. We're not going to have many situations where things mean the same thing. So that's the first useful fact. The second useful fact is that 1 times any number is itself. Like some of the student says, I figured, but that sounds like my worst nightmare. It was very, very. I had to sit there for a second when I was reading reading my textbook. I was like, "What the hell am I reading?" Like a bunch of definition chasing, essentially. So, for example of this, if you had 1 times -5, that would just be itself. It would be -5. If you had 14 times 1, that would just be itself. It would be 14. Multiplying any number by 1 results in the same thing. Same thing. And dividing by 1 keeps the number the same. 3. Dividing by 0 i.e. 0 in the denominator, is undefined. We call it undefined. You cannot divide by 0. So for example of this, if you have 3 over 0, that's 3 divided by 0, that's undefined. We can't divide by 0. And if you have any questions about that, feel free to ask. And another example, if you had -7 divided by 0, that would also be undefined. We cannot divide by 0. And that has to do, there's a good way to explain that. I don't have enough time in this course. Great question. So a student says, what if 0 is on top? That is an excellent question. What do you think it would be? So here's the way to think about why this is undefined. How many times, so when you're dividing, you're really asking yourself, how many times does the bottom number go into the top number, right? If I have 20 divided by 4, how many times does 4 go into 20? It goes in 5 times. How many times does 0 go into 3? It's impossible. No matter how many times you iterate 0, you're never going to get up to 3. So that's the reason why. But that's the next property. So property 4, 0 divided by any number, any non-zero number, is 0. So if 0 is on top, then it's going to be 0. So as an example of this, let's say we had 0 over 5. That's going to be 0. And 0 divided by 2 is 0. Now, why is that the case? Going back to this idea of how many times does it go into something, how many times does 5 go into 0? 0 times, right? You can't put 5 into 0. There's 0 fives in 0. Like 20 divided by 5, there are 4 fives in 20. But there are 0 fives in 0, if that makes sense. So 0 divided by any number, save for 0, is going to be 0. And the last property for today is that 0 divided by 0 is what we call indeterminate. Indeterminate. Which is different than undefined, because the question of how many times, don't worry, I'm coming right back to this. The question of how many zeros go into, how many times does 0 go into 3 is a lot different of a context than how many times does 0 go into 0. There's no real way to answer this question. What is 0 divided by 0? How many times does 0 go into itself? Because technically speaking, 0 could go into itself once, but since 0, adding zeros together doesn't change anything, you could actually have infinitely many zeros going into 0. It wouldn't change anything. So 0 divided by 0 is what we call an indeterminate thing. There is no way to determine what it is. There are other situations where you have something that is indeterminate, but those are later on in mathematics. Those are things that you usually start to see in calculus and beyond. So that'll about do it for today, unless there's any questions on these 5 rules. And it doesn't look like there are. But thank you guys for being so interactive, and thank you for asking those questions. It's my favorite. I said it before, but I'll say it again. It's my favorite thing about being a teacher is trying to answer questions, because it makes me a better teacher, because I see what you guys are learning and where you're struggling. So, anyways, that'll be it for now. If you have any questions, feel free to email me. Otherwise, I will see you guys tomorrow.